Hi guys, today I thought we'd start off with looking at a bit of basic differentiation. Typically this is sort of like what you start off with at A level. Could be a bit of ad maths, GCSE, but typically it's A level. Now, dy over dx is what we often write. And your D represents your change in. So actually it's all Greek letters, a lot of it in maths. And sometimes you could have it as a triangle. And the lowercase of the triangle symbol in Greek is your letter D. Now your dy over dx represents your change in y over your change in x, or effectively your gradient, how steep your line is. Now, if I have something like y equals ax to the power of n, then your gradient, your dy over your dx, your change in y compared to your change in x, is a times n times x to the n minus 1, or an x to the n minus 1. So an example, let me zoom up, go up. If I have y equals 2x to the 4, your gradient, dy over dx, is 2 times our 4 times by the x to the 4 minus 1. So therefore your dy over dx is 8x cubed. So then if you were saying like, oh, what's the gradient when x is 3? Well, then you plug in 3 into this. This graph hasn't got a constant gradient, most of them don't. If I have a little graph like that, I don't know how good this is going to be. Oh dear, I've zoomed in. Need to zoom in. Let's zoom in. Yeah, oh dear, that didn't work. Let's have that bit of it, and it goes up like that, the same sort of shape. So the gradient of this constantly changes, and you then end up saying, oh, the gradient is a certain value at a certain point. Okay, let's go to the other side, me as well. So we've got all that. And let's do another example. So if I have something like y equals 4x cubed plus 3x squared plus 7x plus 9, and I want to find, find dy over dx or something like that. Well, what we end up doing is treating them each separately. So dy over dx is 4 times 3 times x to the 3 minus 1 plus 3 times 2 times x to the 2 minus 1. We then have plus 7 times, well, normally this is actually just represented as x to the power of 1. So we're timesing that by, okay, that's black, may as well, times 1 times by the x to the 1 minus 1. And then your last bit, well, I change to green. 9 can be represented as x to the power of 0. So in this case, we plus 9 times 0 times x to the 0, in theory minus 1, but actually with that bit, this bit here will just disappear. So this disappears. because we've got 9 times 0, and anything times 0 is 0. So let's look at this. So dy over dx, your gradient, 4 times 3 is 12, and then we have x, so 3 minus 2 is 2, so 12x squared, plus 3 times 2 is 6. And then we have x, the 2 minus 1, so it's just x to the power of 1. Then I've got 7 times 1 is 7. And then we have x to the power of 1 minus 1, or x to the power of 0. And anything to the power of 0, which hopefully you've learned at some point, is 1. So that's like doing 7 times 1, which is just 7. So our gradient in this time, or our change in y over change in x, is 12x squared plus 6x plus 7. Cool, let's go on to the next page. You can see I've drawn this graph, and here's the axes, and here is a curve, and they could just write something like y equals f of x. Now, if I quickly draw this line, this green line, and I move it around, this green line is representing something called a tangent. And as you can see, if I just line it up at that point, we have this green line has actually the same gradient as the black line at this point. And that is kind of what we call the tangent, or what's purposely called the tangent. So if I change the gradient, I change the point. So the gradient of the black line changes depending on where you are on it. I go down like that. See the tangent there, it's now moved because it's got a different gradient. So here, the gradient of the black line is now the same as the gradient of this green line. And keep going around, and you see it constantly has a different gradient because it's a curve. If it was a straight line, it has the same gradient. And this black line could be whatever. It's kind of part of a circle, in fact, but it's just the easiest with this new app. So delete that. I want green, and this is what's called your gradient. And your gradient will have a equation of y equals mx plus c, where m is your gradient and c is your y intercept. So let's just say I have, find the tangent when x equals 2 for y equals x squared plus 4x plus 100. May as well just put in the 100 there. So, first of all, actually, we're going to first time find y. We can use that by, let's change the black way as well, using this 2. X equals 2. So y equals 2 squared plus 4 times 2 plus 100. 2 squared is 4 plus 2. 4 times 2 is 8 plus 100. 8 plus 4 plus 100 is 112. So I now know, in terms of, at least on this graph, I'm representing that as 2, is this point here is 2, 140, 112, little mistake there, don't really matter. Good thing about this, I can just delete it all. And I'm going to go down. So we now have y, but we now need to find dy dx, our gradient. So dy over dx is 2 times x, the 2 minus 1, plus 4 times 1 times x, the 1 minus 1, and the gradient of 100, this bit just disappears. So this bit here is 2x plus 4. So when x equals 2. Dy over dx is 2 times 2 plus 4. 2 times 2 is 4. Plus another 4 equals our 8. So our gradient of the tangent equals 8. So we now have our x and y's. So we have our x is 2, our y is 112, and we now know the gradient. So if I just might as well change colour to a blue. So if I have y equals 8x plus c, so this 8 comes from the gradient, so I know the gradient of my tangent's 8, and now I'm going to just plug in the numbers. So we have x is 2 and y is 112. So x equals 2, y equals 112. So 112 equals 8 times 2 plus c. So 112 is 16 plus c. And I want to get rid of 16. So to get rid of a positive 16, we're going to take away 16. So 112 minus 16. So if you're not sure, let's just say the calculator's broken itself. You can always do a little subtraction like this. 2 minus 6 you can't do. Turn that into a 0, puts the 1 up there. 12 minus 6 is 6. You got 0 minus 1 you can't do, so that deletes that. Take 1 off there, puts that into a 0, puts a 10 there. 10 minus 1 is 9. So 96 equals C. And the final step is actually just write the equation now. So our final answer is y equals 8x plus 96. And then that's the equation of the tangent. So you've got y equals mx plus c, and you've got this equation here. So y equals x squared plus 4x plus 100. We then plug in the value 2 into the equation to find out y. We then differentiate it to find the gradient. So it doesn't matter which order you do that in, but you've got to do the gradient, then what the value of y is, all the other way around. Once you've got the gradient and you've got the value of y, you can then plug into y equals mx plus c style, y equals 8x plus c. You then substitute in the 2 and the 112 to work out what c is. And that then gives you your final answer of y equals 8x plus 96. So you might have it where they have something like this. F of x equals 12x squared plus 7 over x plus 93. Find f dashed of x. So we got that. Now, when you differentiate things, you find another word for that is something called differential. So a differential of it. So this is representing a differential of f of x. So I have to find that differentiated. All I've got to do is differentiate this. Now, we've done this in the past, just a moment ago, where we have 12x squared, and you multiply it. But this one, well, how can we do that one? Well, that's just, well, this is actually just x to the minus 1. So what we often do in maths is we rewrite it. So you've still got the 12x squared, but this is now 7x to the minus 1. And then that's still plus 93. So if I've got to differentiate this, or f dash of x, that's 12 times 2 times x to the 2 minus 1 plus 7 times minus 1 times x to the minus 1 minus 1. And in this bit, disappears. Just numbers. If you've got just a number, it disappears. So our f dash of x, or differential of f of x, is 24x. So 2 times 12 is 24, and then 2 minus 1 is just 1, so that's x power 1, or just x. And then you got 7 times minus 1 is minus 7. X to the power of minus 2. Or you could just have 24x minus 7 over x squared. So those two, this here and this here, are exactly the same. So this to minus 2 just means divided by x squared. Here we have 6 questions for you to have a go at. Feel free to pause the screen, get a piece of paper and have a go. And we're going to work through these in a moment. What I am going to do though is quickly zoom in, and then we can then have a little closer look, just in case you're on a mobile phone and you can't quite see it properly. So question 1 is find dy over dx given y equals 7x power 4 plus 3x plus 6 over x squared. Question 2, find, well, given y equals 3x squared plus 7x plus 20, find the equation of the tangent when x equals 1. Question 3, given y equals 2x squared plus ax plus b and the tangent of the graph at x equals 3 has the equation y equals 10x plus 100, find a and b. Let's go this way. So the question 4, find the gradient when t equals 10, when f of t equals 4t cubed plus 5t squared plus 6t plus 7. Question 5, given f of m is 7 over m squared minus 5 over m, find f dash of m when m equals 3. And question 6, find the equation of the normal when x equals 3, given y equals x squared minus x plus 100. So I'm going to zoom back out, have a little go at those, and then we'll work through them together. Okay, let's have a little look through question number 1. Find dy dx given y equals 7x power 4 plus 3x plus 6 over x squared. Now the very first step I'm actually going to do is rewrite the equation, but this bit at the end is 6x to the power of minus 2. So y equals our 7x to the 4 plus 3x plus 6x to the minus 2. Then what we do is we go through the process. Dy over dx is 7 times 4 times x to the 4 minus 1 plus 3 times 1 times x to the 1 minus 1 plus 6 times minus 2 times x to the minus 2 minus 1. So we multiply by the power and then take 1 off the power. So our gradient, our dy over dx is 28, so 7 times 4 is 28, x, 4 minus 1 is 3, so 28x cubed plus 3 times 1 is 3, and then we have 1 minus 1 is 0, and anything to the power of 0, other than 0 itself, is just 1. So that's like going 3 times 1, so that's just 3. We have 6 times minus 2, so 6 times minus 2 is minus 12x to the minus 3. And that's it. So our answer is 28x cubed plus 3 minus 12x to the minus 3. And you could have this bit at the end 12 over x cubed. Let's have a little look at question 2. So given y equals 3x squared plus 7x plus 20, find the equation of the tangent when x equals 1. So the first thing I'm going to do is find the value of y. But you could find the gradient or dy dx first, but it doesn't matter. But I'm going to do y first. So what we're all going to do is plug in the value of 1. So y equals 3 lots of 1 squared plus 7 lots of 1 plus 20. 3 times 1 squared is 3, plus 7 times 1 is 7, plus 20 equals 30. So that gives us y is 30, and we can even write it as a coordinate of 1, 30. So now we need to find dy dx, our effective gradient. Dy over dx equals, well, 3 times 2 times x to the 2 minus 1 plus 7 times 1, because that's x to the power of 1, times x to the 1 minus 1, and the gradient of the 20 just disappears. So our dy over dx is 6x plus 7. Now, when x equals 1, our gradient, our dy over dx, is 6 times 1 plus 7, which is 6 times 1 is 6, plus our 7 is 13. So we now have our gradient. And we also have a point on the line. So, go that way. We're going to use the form y equals mx plus c. So y equals 13x plus c, and I have the point 130. So 30 equals 13 times 1 plus c. So 30 equals 13 plus c, and therefore c equals 17 by taking away this 13 here. And our final thing is then to write the equation. So y equals 13x, that's our gradient, plus our c, which is now our 17. And that is the answer. So I'll have a little zoom out. You can have a little read. The side's got chopped off a little bit. And there we go. Let's have a little go at question 3. Given y equals 2x squared plus ax plus b, and the tangent of the graph at x equals 3 has the equation of y equals 10x plus 100, find a and b. So our first step in this is thinking about, okay, what do we know? Well, we know that the tangent has a gradient. Tangent has a gradient of 10. So this means when x equals 3, our dy over dx equals 10. Our gradient equals 10. So at this point we're going to find dy dx. That's what changed to blue. So dy over dx is 2 times x to the 2 minus 1 plus a times 1 times x to the 1 minus 1, and then plus nothing. So actually we're not even going to bother with that. Let's might as well delete it completely, because the b disappears. So dy over dx, 2 times 2 is 4, and then we have x to the power of 1, or just x. And then we have a times 1 is a, and then that's x to the power of 0. Now I'm going to use this when a tangent has a gradient of 10, or dy dx equals 10 when x is 3. So let me scroll down. 10 equals 4 times 3 plus a, or 10 equals 12 plus a. And therefore a equals minus 2. Okay, now we have the equation y equals 2x squared plus ax plus b. We now actually know what a is. So we have y equals 2x squared minus 2x plus b. Now what else do I know? Well, I know that our tangent has an equation of y equals 10x plus 100. And we know actually what x is. So we can actually work out what y is. So this tangent, I might as well write it here, when x equals 3, our y equals 3 times 10 plus 100, or equals 3 times 10 is 30 plus 100 is 130. So what else do we know? Well, we know that point. So we have 3, 130. So I can actually plug in those numbers. 130 equals 2 lots of 3 squared, which we know is a 3, minus 2, let's delete that one, I've fluffed that one a little bit, but who cares, we all make a little mistake, minus 2 lots of 3 plus b. So 130 equals, well, 3 squared is 9, times our 2 is 18, minus 2 times 3 is 6, plus b. You got, basically that's 12. So 130 minus the 12 equals b, and therefore b, little b, equals 118. So now we've worked out what b is. So we've worked out what b is, we've worked out what a is. A equals minus 2. And that's the whole thing. So you basically go down the route of, you find your dy dx, and you can then solve to find a, and you can then use the value of y, which you've worked out, for that value of x to work out what a is. Let's have a little look at question 4. We'll find the gradient when t equals 10, when f of t equals 4t cubed plus 5t squared plus 6t plus 7. Now, with this one, we don't write dy dx because there's no y's and no x's, although this is my third attempt, because I have been writing f of x and actually it was f of t. Now put a little dash like that on there, and that represents the differentiated version of it. Now f dash of t, well, you've got 4 times 3 times t to the 3 minus 1 plus 5 times 2 times t to the 2 minus 1 plus 6 times 1 times t to the 1 minus 1, and this bit here, the 7, the gradient of that is 0. You're doing 7 times 0, and then it just disappears. So f dash of t is 4 times 3 is 12 t squared plus 10t plus 6. And all we do now is plug in t equals 10. So f dash of 10 is 12 lots of 10 squared plus 10 lots of 10 plus 6. So that's 10 squared is 100. So we have 1,200 plus 10 times 10 is 100 plus 6. So that is equal to 1,306. So find the gradient when t equals 10, 1,306. Okay, question 5. Given f of m equals 7 over m squared minus 5 over m, find f dash of m when m equals 3. So let's have a little gander through this one. First of all, I'm going to rewrite this. So f of m is 7m to the minus 2 minus 5m to the minus 1. We then differentiate it. F dash of m is 7 times minus 2 times m to the minus 2 minus 1 minus 5 times minus 1 times m to the minus 1 minus 1. So our differential f dash of m, no, I've done it again, that's not the first time, let's just carry on anyway. F of m, we always do that often with students. We're so used to writing f of x, we just write f of x all the time, even if it's m or a different letter. So 7 times minus 2 is minus 14, m to the minus 3, minus 5 times minus 1 is actually plus 5, m to the minus 2. Now I'm going to rewrite this as f dash of m is minus 14 over m cubed plus 5 over m squared. Now we have a little look. I've got to find it when m is 3, so m equals 3. So our f dash of m is minus 14 over, well, m cubed, so 3 cubed is 27. It's just writing 7 wrong way. Plus 5 over m squared, so m squared is 9. Now what I'm also going to do now is make them the same in terms of the bottom. So I'm going to times this by 3, top and bottom. So f dash of m is minus 14 over 27 plus, well, 5 times 3 is 15, 9 times 3 is 27. So our final thing, our f dash of m is, well, 15 minus 14 is 1 over 27. There we go. So f dash of m when m is 3 is 1 over 27. Okay, final question, question 6. Find the equation of the normal when x equals 3 given y equals x squared minus 4x plus 100. So if you're not sure what a normal is, you can always, will be other videos. But you've got your graph, which could be like y equals f of x. And we did look at earlier the tangent, which is the gradient of the line. Now the normal is at right angles to the tangent, or right angles to the line. And the gradient of the normal is the negative reciprocal to the gradient of the tangent. So if gradient of tangent equal 10, and normal gradient, let me move down, would equal minus 1/10. Okay, and that's not saying in this example question that we have a gradient of 10, but I'm going to delete that because you look back at this and go, yeah. But if you had a gradient, the tangent had a gradient of 2, the normal would be minus a half. If the tangent had a gradient of a third, the normal would have a gradient of minus 3. So it kind of like flips the fraction, but we'll go over negative reciprocal in other videos. So let's have a little look at the question then. So find the equation of the normal when x equals 3 given y equals x squared minus 4x plus 100. Well, the very first thing we're going to do is actually differentiate it. So dy over dx, differential of x squared is 2x minus 4. And when x equals 3, our dy over dx is 2 times 3 minus, that's often the case, really be careful, minus 4. That's 6 minus 4 is 2. So our gradient of the line equals 2. And therefore the gradient of the tangent, of the, not the tangent, the normal, equals minus a half. We also have this thing of, we need to find out what y is. So y equals, see if I can get it in the page. Well, when x is 3, so y equals 3 squared minus 4 lots of 3 plus 100. 3 squared is 9, 4 times 3 is 12, plus 100. 9 minus 12 is minus 3, plus 100 is 97. So we now have the coordinate of 397, and we then have this y equals mx plus c. So y equals minus a half x plus c. We're going to plug in x is 3 and y is 97. So 97 is minus a half times 3 plus c. I'm going to make it as a decimal as well. 97 equals, well, half of 3 is 1.5 or 1.5. So we have minus 1.5 plus c. And therefore c, we're going to add this 1.5 to that, is 98.5. Our final equation is y equals minus a half x plus 98.5. And that is our equation of our normal. Might as well circle it. And then we can zoom out and you can have a little look. So our normal has a negative reciprocal gradient to the tangent. Hi guys, if you've enjoyed this video, please consider subscribing or even helping me a little bit on Patreon. It's patreon.com/MP the tutor, and this helps me make some more videos and dedicate a bit more time, and you can help by some hand wash or some loo roll, and I'm also sending out some free books, so up until the end of April, no matter which one you sign up for, I'll send you out a hardcover 192-page custom design notebook, and potentially a few. I'm hopefully just going to make a couple of videos a week, just to support as many people as I can, whilst everyone's off school for the next 6 months. Thank you very much, and have fun watching these videos and having a go.